We're going to talk about the join fundamentals today. So I'm going to be assuming that you're familiar with joins already. You can do a left join, you can do an inner join, maybe a right join, full join, cross join. At least you're familiar with some of them. But this is just going to be laying out the syntax, just so that you're comfortable with how pretty much all SQL databases do joins. If you've never done a join before, this is not the video for you. I've got a separate video on an introduction to joins, specifically for people that know Excel. I'll link it above. If you're not familiar with Excel, there's going to be loads of other SQL join tutorials online. Please check them out before you come to this video. Let's remind ourselves of the 5 different join types, the fundamental join types anyway. And to do this, we're going to use some sample data. This is website data, so customers or users trying to log into a website. So we've got a few sample users. We've got a table that tracks the Google authentication. So if you're trying to log into a website and you're using the sign in with Google, there's one where it's sign in with email and password. It tracks which users have used that approach. And also a table that tracks the events, so the login and the logout and the login failed events. So this isn't real data, of course. This is just some sample data just to try and remind ourselves how joins work with data that looks like this. But I'm going to hide this for now. Let's start with a good old left join. So let's say we start with our events table. Let's do a select everything from events. We've got a fair bit of info. We've got the number, the event number, which user did this, the time that the event happened, and what the event is. This has the user ID, but what if we wanted to get the user name, which remember we had in the users table? Let's say we wanted to get the user name next to this. Well, this is a perfect use case for a left join. So let's just quickly list out all of the columns that we have in the events table. And then we're going to write a left join on the users. For a left join, we always need a join condition. So we'd write on something. In this case, the way that we associate the events and the users is via the user ID. So we'll take the event user ID. We'll have that equal to the user's user ID. That's how we relate these two tables. And since we're doing a join, we should be explicit about where these columns come from. These all came from the events table. And specifically what we want to get from the users table is the username. So let's give this a run to see how it changes our output. Okay. It's exactly the same output, but now with the username. And we know that this is correct because user ID 1 was Alex, 2 was Blake, if we scroll down a smidge, 3 was Charlie, and so on. So the left join was how we got all of the information that we needed on the users table onto the events table. While we're here, let's talk about the right join as well. Right join almost never comes up. We might talk about it in a future video, cases where you would want to use a right join, but a right join is like a left join but the other way around. What do I mean by that? Well, another way that we could have written this query was using users first, events second, and right instead of left. The output is going to be absolutely identical. And because it's identical, that's why people typically stick to doing a left join. It's just easier to think about left joins than it is right joins, just because we're more familiar with them. So my recommendation, stick to left joins. We can use a right join. They're included for completeness. There is, or at least historically, there were very few use cases for right joins, which don't quite exist so much anymore. So stick to left joins, unless you know that you want to use a right join. But for the rest of the videos, I'm going to pretend right join doesn't exist, for the most part, because any right join can always be written as a left join. Do you remember how a left join differs from an inner join? Let's go ahead and swap around the order of these. Let's start with the users join on the events. And because I'm pedantic, let me take my user information and put that first. And instead of using the events, that's not the right one. Instead of using the events user ID, let's use the user's user ID. So I'm going to give this a run. In this case, if I scroll down enough, you'll see that we get some nulls for user ID 4 for Dylan, because they don't have any events. There are no events in the event table corresponding to Dylan, corresponding to this user. So when I do a left join with the events, starting with the users, we keep Dylan because they're in the users table, but we don't get any event information for them because they haven't had an event yet. The difference between a left join and an inner join is that an inner join would drop Dylan because we couldn't find any events for them. Let's prove it. Let's just quickly do inner join. I'll rerun this one. We'll scroll to the bottom. There's no more Dylan. And remember, if we don't specify a join type, if we just write join, that defaults to inner as well. I'll rerun this just to prove it. There we go. So if you're working with unfamiliar data, my recommendation is always start with the left join until you know you want to use an inner join, because an inner join is going to drop data. That's not always bad. Sometimes that is what you want, but you need to bear in mind, you need to keep in your mind that inner joins drop data if they cannot be found in your join condition. So that's left, right, and inner. Let's talk next about cross join and full join. And we're going to use the other two tables to illustrate these ones. So let's just remind ourselves what the Google Auth and the password auth was like. This has a row per user when they last used this authentication mechanism and some of the important information associated with that authentication type. Let's just start with a cross join. So let's do a select star from, give us a bit more space. We'll start with Google Auth. We'll do a cross join with password auth. If you've never used a cross join before, the special thing about a cross join is that you don't need a join condition. A cross join will match every row with every other row in the other table. So let's see this in action. If I run this one, we end up getting 6 rows back. And that's because each of the 2 rows in Google Auth have been paired up with the 3 rows in password auth for a total of 6 rows. So let's see this. User ID 1 from Google Auth has been paired up with all 3 of the users from password auth. And similarly, user ID 3 in Google Auth has also been paired up with all 3 users from password auth. This isn't typically what we want with data that looks like this. It's more common to do a cross join with a table that has 1 or 2 rows. Typically, maybe you might set up some variables in a CTE. So if you aren't comfortable with CTEs or subqueries, you can skip this bit. But sometimes you might do some variables in a CTE. So you might do something like current date and some manipulations on current date. Remember, if I run this bit, we're just going to get a single row back with a single column. You might cross join on your vars, because there's no way of associating these 2 tables. But you'd do a cross join so that you can get whatever variables you set up in your vars CTE available in your Google Auth table. So this isn't an ideal example, but it's just one of the ways in which people use cross joins. But other than that, cross joins aren't really that common. And while we're here, if I take this back, rerun this one just to remind ourselves what the output looks like. It's worth remembering that the cross join has an alternative syntax. This is the ANSI syntax, which we'll talk about in another video, but it's exactly the same as writing a query like this, with a comma between your 2 tables. This will also do a cross join. So let's rerun it to prove it. We get exactly the same 6 rows on the output. Now, the final join type to run through is the full join. So let's write full join. And this is like the other join types. We have a join condition. In this case, how would we associate the Google auth with the password auth? Whereas the user ID is the unique way of identifying rows in either of these tables. So we would join it on the user IDs. So we'll start with the Google auth user ID. We'd want that to be equal to the password auth's user ID. And this is how we associate these two tables. Let's list out some of the columns. So let's do Google auth's user ID. Just so that we can see them side by side, let's also do the password auth's user ID. And then we'll list out the corresponding information. So let's do Google auth. We'll do their Google token. Then we have password auth. We're going to have their email. And we're going to have their password. I'll skip last accessed for a moment. And let's give this a run. So this is what's interesting about the full join if you've never come across it. It keeps all rows in both tables. So in this particular case, we actually end up with a table that has the user IDs for all 4 individuals. It's just only one user exists in both tables. So we have the information for user 1, we have the information for Alex, both their Google token information and their email and password. But user 3, Charlie, has only used the Google authentication mechanism. So we've got a Google token for them, but no email or password. Similarly, 2 and 4, Blake and Dave, is it Dave? Blake and Dylan, they haven't used the Google auth authentication method. So we've only got email and password information for the 2 of them. Just to compare it, a left join wouldn't be sufficient here. If we did a left join, we would keep everything in Google auth and only join on the stuff from password auth where a match exists. So if I run this one, we only get 1 and 3. If we did an inner join, we'd only get user 1 because my program's transposed it. Let's undo that. We'd only get user 1 because that's the only user that exists in both of these tables. Similarly, if we were to do a right join, then we only get users 1, 2, and 4 because password auth only has 1, 2, and 4. We need a full join. We need to keep both rows in both tables in order to see all 4 users in the output. So I love full joins. I don't use them particularly often because it's somewhat rare that you need to do them. But when you do need to use them, they can be so massively helpful. And typically, we wouldn't want to keep the user ID in both columns. Typically, we would want to do a coalesce of both of them. We'd want to keep both of these. And the order of the coalesce doesn't matter because in the case where they're both not null, they're going to be the same because that's the condition that we're joining on. So if I delete this and rerun this one, you can see we now have a complete user ID column. And then we have the associated Google information or password information for those users. So full joins, absolutely fantastic. I love a full join. Okay, we've reminded ourselves of what I like to call the fundamental join types, the 5 that we've just run through. So let's just remind ourselves as well, just some of the syntax and some of the ways that we can use them. I haven't mentioned it so far, but the left join, let's actually make this some valid SQL first. Let's do events, left join, users. The left join can also be written left outer join. It's the same with right, and it's the same with full. In SQL, left, right, and full are all considered outer joins compared to an inner join. But the outer keyword is completely optional. And in fact, it does absolutely nothing. And since it does absolutely nothing, I'm going to recommend you forget it exists. It's sufficient just to write full join, left join, right join for these 3 outer joins. Like I mentioned, inner join is then a special different type of join, and cross join is another special type of join. But they're still your 5 fundamental join types. And these 5 will be in pretty much every database that you use. So of all databases that I've used, only one database has not had all 5 of these, and that's SQLite. SQLite doesn't have the full join. This one, full. But every other database that I've used has all 5 of these. So for the most part, you can assume that if you're writing some SQL, it's going to have all 5 of them. But just watch out for the full join. When we do joins, we can do as many joins as we like. So far we've just been doing 2 joins, in this case users, and then left joining on the events, but we can join as many tables as we like. We can join with the Google auth and with the password auth. We can add as many as we want. And we don't have to use all left joins. We can have some left, some inner, some full. You can mix and match your joins however you fancy. As long as it's valid SQL, you can do your joins however you want. Just make sure that you get your join conditions correct for your corresponding join. I won't go into it in much detail, but I will also mention that you can always join a table to itself. These tables aren't really set up to do that, which is why I'm not going to run through an example. But this is what we would commonly call a self join. So there isn't a self keyword that you could use like this. That doesn't exist. You would have to choose one of the existing join types, say left join, but you can reference the table twice, both in the from and in the join. But when you do this, you need a way to distinguish between whether you're doing the one in the from or the join. So you would just add an alias, maybe users1 and users2. I would recommend more semantically appropriate names. But then anytime you would reference a column in either of these tables, be explicit about whether it's the one from the from, users1, or the one from the join, users2. While we're here, I'll also mention that you can do a left join with a subquery. Again, if you've not used subqueries or CTEs, you can skip this part. But it's worth using, worth knowing about this. So we could do some subquery. So we get all of the events from the event table where the event date time is greater than 2024-02-01 midnight. This is a subquery because it's a select query that's wrapped in brackets. So this is a subquery, but we can still left join to it if we want. In order to be able to join to this correctly, we're going to need to give it a name. So we might call it filtered events. This is the alias that we're going to give this subquery so that we can still do a join with it. This would be on user ID is equal to the filtered events user ID. Let's just run this just to prove that it works. Here we go. In fact, this works, but there's no events after this particular date time. So let's do a slightly more reasonable one. Here we go. So we still get some events. This join still works. We're just doing the filtering inside a subquery. If you're comfortable with common table expressions as well, CTEs, that's why you can join with CTEs. So if I was to turn this subquery into a CTE, I'll just take the name up to the top. I'd wrap the subquery up here. And then I'll just refer to the subquery in the left join instead. So I'm just going to give this a rerun to prove that it still works. Here we go. And pretty much all of my SQL, I've been writing SQL for years, pretty much all of my SQL will have common table expressions because it's easier to just do transformations or individual smaller SQL queries in the CTEs and then use those CTEs in other smaller SQL queries just to knit your data together in small bites. It's a lot easier to understand what's going on when there's lots of small subqueries going on. In this case, a subquery, when we're doing it after the with clause, a subquery is called a common table expression, a CTE. If you want to know more about subqueries and CTEs, I've got a video about them. I'll pin it up the top right so that you can have a look at it. The last thing that I'll mention is that when you're doing a join with a condition, whether that be a left join, right join, full join, or inner join, remember cross joins do not have a join condition, you can write any condition that you want. So far we've been writing equals because that's how we associate these, but we can have any conditions in here that would be valid in a where clause. What I mean by that is that we can have multiple conditions joined with ands. So actually, rather than filtering the events in a subquery, we could filter them in the join. So if we filter on events instead, but additionally specify that the event datetime from the events table has to be greater than or equal to this timestamp, we've done exactly the same thing without having to use a subquery. We're going to join the users to the events table where the user IDs match, because we only want to associate the events with the correct user. But additionally, we only want to keep the ones whose event date time is later than this timestamp. So let's give this a run just to prove that it works. It sure does. And just to make this output a little easier to read, let's just quickly list out the columns that we care about. So in this particular case, let's care about the user ID, the user name. We'll skip the review date, but let's keep the event ID. We've already got the user ID from the users table, so we can skip the user ID in the events one. But let's keep the event date time and the event type. So I'm going to rerun this just so that we can see the updated output. Here we go. And we can see that all of the events are after this date. I'll just order by it just to make sure it is indeed. And because we're doing the left join, we didn't find any events for Dylan. So we still see them because they're in the from the users, but just all of their event information is missing because there's no events for Dylan. We can have as many conditions in here as we want. We can just knit as many ands together as we want. We can add ors in if we wanted to as well. It's totally up to you. As long as whatever you have here would be valid in a where clause, you can add it here. I want to make a word of warning though. Do not get your join conditions mixed up with your where conditions. Let's see what I mean by this. So if I run this one, let's do an order by the event date time, so we can get our events in order. Could also order by the event ID, doesn't matter. We still have our line for Dylan, for user ID 4. This is because we're doing a left join with the users, or we're starting with the users, we're joining on the events, and we're keeping the rows in the events where this is true. I want to be really clear here that this is happening in the join part. This is how we glue rows from events onto users. According to this condition, and even without the event date time, as we saw earlier, Dylan doesn't have any events. So when we do this left join, we've reduced the number of events that are matched with our users, but Dylan still has none of them. Now, what if we had decided to do this as a where condition instead? If we had done this as a where condition, what do you think is going to happen? Let me run it to find out. If I scroll to the bottom, Dylan's gone. This is super, super important. Make sure you get your conditions in the right place. The where has dropped Dylan because when we did the join with Dylan, we couldn't find an event date time for them. So when we compare Dylan's event date time with this date, there are no rows that meet this condition. So we kept Dylan in the left join, but we then dropped them with the where. Just to compare, let's put this back to the and on the left join. How does this differ? We have the Dylan row. Because this is the logic that we're using to associate rows in the join, not the logic that we're using to filter the rows on the output. So this is just a word of warning. It might take a little bit of time to wrap your head around it and get used to it, but doing a left join with a set of conditions is not the same as doing a where with some of those conditions. Let's jump back to the full join that we saw earlier. Let's give this a rerun just to remind ourselves what the output looks like. In this case, we used the COALESCE on the user IDs to make sure that we had a complete user ID column. And then the remaining 3 columns would have information where it was available for that particular user in the given table. One of the important things about our join condition here is that it's on the user ID on the left table is equal to the user ID on the right table. Now, a lot of databases provide us with a different join condition syntax that we can use. So instead of writing on, a lot of databases will allow us to write using. And then after using, we specify some brackets, followed by the names of the columns that we want to join on in both tables. In this particular case, we want to join on the user ID in both tables. Note that this only works when the column is the same name in both tables, because using is going to expand out to an on clause. So you can think this expands out to this. What's convenient about this? Well, so much less to write. We know that user ID exists on both tables. So writing join using the user ID, well, of course, that must mean that we're using the user ID from the auth table, the Google auth table, and pairing that up with the user ID on the password auth table. So let's run this just to prove that it works. Of course, there we go. So using is a fantastic keyword to use instead of on when you're joining on columns that have got the same name, and it's equality in those columns. There is special cases to that, but for the most part, you want the columns to be the same name, and you want the columns to be equal to each other in both your tables. Of the databases that I use, SQL Server is the only one that hasn't supported using. So if you're using SQL Server, the Microsoft SQL Server, or Transact SQL, T-SQL, or the Azure SQL, any of those that fall under the Microsoft category, you can't use using generally. You would stick to using the on join condition. But for other ones, Postgres, DuckDB, SQLite, Snowflake, you can use this using keyword to really streamline your join conditions. So using is one that I use all the time, especially for small joins like this. Some people don't like the using keyword because, and particularly when there's lots of joins, because it's not always clear how this expands out into an on. So there is some nuance to where it should be used without there being ambiguous results. But in general, it's a fantastic choice for a join condition. There is one additional benefit that we get from using. Since the using is a quality on the columns that we specify inside the using brackets, and I'm not going to run it because it won't work, but if we wanted to specify multiple columns, we would just specify multiple columns inside the using separated by commas. Typical SQL syntax for listing multiple columns. But the additional benefit is that we don't need to specify a table prefix for that column in the select. So if I delete this part here, in fact, we will also not need the alias there as well. If I just write user ID, then SQL behind the scenes is going to do the coalesce for us. So if I delete this and rerun it, it's already done the coalesce on the user IDs. So the choice to actively not prefix this column with one of the two tables and using the using join condition actually has a benefit. It will automatically do the coalesce for us. This can be really useful, particularly when you have lots of joins that are all on the same condition. So if we also wanted to do a full join on the events, also on user ID, that will do the coalesce of all 3 tables worth of user IDs. Saves you a lot of time, saves you a lot of error. It's error prone writing that much coalesce. And it's just so much nicer to see it this way as well. So that's one of the reasons I'm really disappointed with SQL Server, because using isn't just a nice shorthand syntax to use. It really does give added benefits to how we write our select queries as well, our columns in our select part of our select clause. So I do really like using. It's one of the join conditions that I use regularly. I will regularly use using unless I feel like I need to be explicit. If I feel like somebody could read a query of mine and get confused about what columns are being used in a using clause, that's when I'll be explicit with an on. But the rest of the time, I stick to using. It's easier to write, and it's easier to write the select clause as well. Let's go back to our join between users and events. I've been saying so far that for a left join, for all the other non-cross joins, so left, inner, right, full, you have to write a join condition. That could be on. We'll run this just to prove that it works. It could be using that we've just seen. So again, I'll delete this and run this just to prove that it works. But we don't always have to write a condition. There's a special keyword that a lot of SQL databases support that mean that we can ignore the join condition and we can let SQL figure it out. Now this keyword isn't used very often because it's actually considered to be quite dangerous. If tables change over time, it could unfortunately break some queries. So we'll see how this works and we'll show why it breaks. This special keyword is called natural, and it's a join modifier, which means that it goes before the join to modify the behavior of that join. So if we wanted to use the natural keyword, we just whack it in right before the left join. So I'd write it here. And the behavior of the natural left join is that we don't need to specify a join condition. So I'm going to delete that. For now, let's just hide the table output as well. The natural join, the natural keyword, it will figure out what join condition to use for us. And the way it figures this out is by looking at the columns on both tables and doing the join on the columns that exist in both tables. So remember, the users table, it's got user ID, username, and the last reviewed date. The event table, it's got the event ID, the user ID, the event date time, and the event type. So the only column they have in common is the user ID. So I'll run this to prove that it works and then just remind us what it's doing. So if I give this a run, just to prove that it works, we get the same 39 rows that we did when we're doing the left join on the user ID. To be really clear, with the natural join, the database is going to look at the two tables and then it's going to construct the join condition for us. You can think of it as writing the using join condition and specifying the columns that exist in both tables. In this case, it's just user ID. So the natural left join, we can think natural left join, this would be rewritten as this. The database is adding the using clause for us. This seems convenient, but because it figures this out for us, it might do unpredictable things if we add extra columns to either of these tables. So I'm not going to talk about it too much, but This is one of the reasons why natural joins straight on tables is dangerous, and why people consider it to be dangerous, because adding columns to tables shouldn't break queries. But that is a risk that you have if you do natural joins between tables. There's ways to obviously construct these so that that wouldn't be as much of a risk, but usually it's more hassle than it's worth. Just to illustrate a place where the natural join might do something that we don't expect, let's go back to our full join example. We're doing the Google auth with the password auth, and we're doing a full join. So we'll strip that out. And for now, let's just do a select star. And remember, we wanted to join the two of these because we wanted to see all users in both these tables. But we just wanted to associate the columns for the rows or for the users that exist in both tables. So we might think, oh, this is a nice place to use the natural full join, instead of being explicit that we wanted to do it on the user ID. If I give this a run, it hasn't paired up any rows. We saw last time when we did this previously that we paired up the user ID in the Google auth table with the password auth table. But why has the natural full join not done it? It's because the columns that we have in common on these tables is both user ID and last accessed. So the natural full join, in this case, would actually expand out to still full join, but the using clause that it would write would be user ID and last accessed. So natural full join would be evaluated to be this. And of course, this isn't correct. We don't want to join the rows on the last accessed column as well. We only want to join them on user ID. When we join just on user ID, we do pair up the rows as we expect. So keep an eye out for natural. This is how it works, but in general, I would say stay away from it. To wrap up, we've actually seen quite a lot of stuff in this video. We went over the 5 fundamental join types, what I consider to be the fundamental join types. That was left, right, full, inner, and cross. We saw that left, right, and full are all outer joins. So you can write the outer keyword if you want, but I don't recommend it. Inner and cross are then 2 other separate types of joins. Cross is special because it doesn't need the join condition. We know that we can have as many joins as we want. We can join to tables as many times as we want. We can even join a table to a self if we really want to. We've also seen that we can have as many conditions as we want inside the on part of a join. It's a great way to really tailor the join conditions that we're using to pick just the rows that we care about from the table that we're joining to. But when we're doing a left join or one of the other types of outer joins, we need to be really careful that we put the condition in the right place. Putting a join condition in the join, or putting a condition in the join might lead to different results to putting it in the where. So make sure you get it in the right place. We also saw that we can join to subqueries and therefore common table expressions, CTEs as well, and that we can even reduce the join conditions using the using keyword instead. This is not supported by some databases like SQL Server, but it's a nice way to reduce the amount of stuff that you have to write in the join condition. And we saw that it had extra benefits where it will automatically coalesce the columns that are specified in the using when we write those without a table prefix in the select clause. We also talked about the natural join modifier that we can add in front of joins, but there's generally a bad idea to use it. So keep an eye out for it, but in general, don't use it. In our upcoming videos, we're going to be talking about new join types. These are the fundamental joins that are in most databases, but we're going to be talking about lots of join types that you may not have seen before. So stay tuned for those ones, and I hope you found this one useful.